Let's grab another one. That was, okay, that's a 3. We'll do the 3. Then we may jump back to university. So a particle with charge of that is moving in the XY plane at 47.5 clockwise from the x-axis. And there's a magnetic field in the x direction, or sorry, the negative x direction. Okay, so it's moving 47.5 counterclockwise. So if we draw the picture, we've got our magnetic field going that way, our velocity is that way. So what's the direction of the cross product? So again, to do that, I put my hand on the V with my palm facing the B. Right? So get up and do that. Hand on the V with palm facing the B. So the direction of V cross B is out of the board. The force, though, remember, has a Q in it, right? The force is Q V cross B, right? V cross B is out of the board, but the particle they gave us in the problem is negative charge. So the negative charge means the force is going to go into the board, which is the minus C direction. Right. Then as far as the magnitude, it's just straight plug into the formula. So QVB sine theta. So my Q is 1.65 10 to the minus 8. My V is 43,000. And theta, well, theta is really this obtuse angle here, but it's actually, sine of it's actually the same as the other one. But let's go ahead and use the other one. So I've got, where's the problem? There we go. So my Q is 1.65. My V is 43,000. And my theta, well, it's really 180 minus 47.5, which is 132.5. There's 132.5, whoops, times 132.5 sine equals 52,000 that. That's the magnitude of the force. Yeah, and they are asking for force. So 52,300. Oh. Wait. Actually, I forgot to multiply by B. Oh. Oh. Ow. It was 52,300. I forgot to multiply by B, which was 2. But that was actually, I was doing the scientific notation part in my head. There's a 10 to the minus 8th on the charge I didn't do. So that's, right now that's times 10 to the 5th, so it's 1.05 times 10 to the minus 3. So just 1.05. Because they have millinewtons. That kind of clued me in that I forgot to do something when I saw millinewtons. It's like, wait, I just got 100,000 as my answer. It's like, oh, because I forgot the 10 to the minus 8. Okay. I should make this big enough where y'all can read it. Y'all should tell me whenever you can't read what it says. All of a sudden I look up there and it's like, oh, wait, y'all probably have no idea
what you were writing. That was the day.
Yeah. So all I did, I took the 1.65 times the 43,000 times the sine of, well, We could have just done sine of 47.5 because it's the same, but strictly speaking, the angle's the obtuse one that's in between the V and the B. So I did sine of 132.5 and then times the D, which was 2. So that's all we did there. All right. What's the direction of the force? Okay, so now we're turning the magnetic field around. We're doing same thing, except now the magnetic field is coming out of the board. So let me pull up my picture again. So if the V is still here, but now kind of imagine the magnetic field coming straight out of the board, then what direction would the force be? You gotta use your imagination a little bit. So. Has to be perpendicular to both those guys, right? So, I mean, if it's perpendicular to the magnetic field, that means it's in the XY plane. So it's still in the, right? So if it's perpendicular to V, there's only two options. It has to be going down like that, or it could be going up like that.
I think it's going up.
So one going up. What do you think, Cindy? So again, imagine putting your hand on the V with the palm facing the B.
Where's the B?
The B is coming straight out of the board.
Oh.
So if I put my hand on V with the palm facing out of the board.
No, it's going downward.
Yeah. So this is the direction.
I didn't know where B was. I thought it was going down. Yeah.
So this, okay, yeah. So this guy's the direction of V cross B. Actually, you can get away with it, Colby. You can say, well, I wasn't talking about V cross B. I was talking about the force. But then the last thing is, remember, the force also has the Q. We have a negative charge particle. The force is going up. Right. So, yeah, that's why I wanted to spend a day just kind of trying to wrap our head around it. I said hand. Of course, I guess we're using the right hand roll, so maybe wrap our hand around it makes sense too. But that's the point, is that the whole, when you actually put everything to the grindstone, it just feels weird because you feel like, okay, the particle is going this way, the field's going that way, it's accelerating that way. It's like, it's weird. So anyway, so the angle, well, it'd be the 47.5 and then plus another 90. So it is, so, okay, it wants the angle from the Y direction, so it's just 47.5. That was the angle we started with, right? Yeah. And then for the magnitude of the force, well, again, the magnitude of the force is just Q times V times B. So let's do that right quick. So 1.65 times V, which is 43,000, times B, which is 2, and then times the sine of the angle between the V and the B. Let's go back to our picture right quick. What's the angle between V and B in that picture? Remember, V is going straight out of the board. So, visual aid. This is B. What's the angle between the V and the B? Okay, V is right here, and B is coming straight out. So what's the angle between B?
90.
Is 90. Yeah. So the sine of theta or whatever is just like 1. So anxious stuff is blowing over the board. More is going out of the board. It's always yeah, if as long as the V is on the board.
Yeah.
And if it's whether it's going in or out, then it's not hitting it. So that'll pull that out, but there's not really anything left to do because so we already had that for V times or Q times V. Sine of theta is 1, so that, and then there was a tenth of the minus 8 I hadn't worried about, so this is 10 to the 5th, so 1.42 times 10 to the minus 3. Make it smaller so I can actually enter the answer. 1.42. Cool. Make good sense. Kind of. Yeah, it's. Man, feels definitely take a little bit of getting your head wrapped around. They're weird. It doesn't feel like, it's like why couldn't we put the force in the same direction as the magnetic field? Is what I want to ask. The answer is because that's not the way God made the world. It's just, yeah, it's just weird. Cool.